Okay, lesson 4, sigma notation today. But just before we go, I'm not sure if we had work to do from, I think we do. We had about 6 questions, if I remember. So let's run through. Yeah, given 5, 10, 20, a geometric, it's a geometric, okay. Determine the nth term quickly. So we have 5, we have 10, and we have 20. Quickly, my R is T2 over T1, which is 10 over 5, and that is 2. The nth term, what is the formula? Tn equals to A multiplied by R to the power n minus 1. My A first time, R is 2, and that is. Please don't multiply to say 10. No. Number 2. Calculate the sum of the first 18 terms. You should have done this. All right. So we just mark in quickly. Sn, our formula, R to the power n minus 1 over R minus 1. So we're looking for sum of the first 18. S18. We have a 5. We have a 2 to the power of 18 minus 1 over 2 minus 1. Okay. Just going to run because I really want us to get into sigma notation today. 5, some people are in a hurry to see what the sigma notation is. Oh, 2 minus 1 is 1. 131 0715. 131 0715. And your questions are done there. Let me know if we are okay with that. Responses will be appreciated quickly. Okay, and that is that. You got to be, you need to probably take pictures of this, send to the group so that you can have reference for the question and the solution. And those who are missing the lesson now can also see. But I'm going to request that the pictures go very fast. The lesson is also going to be quite short today, so I'm going to need the response as quickly as possible. Send a picture if you're sending. All right, I believe you have it. Next one. The following sequence is a combination of arithmetic and geometric. Nice one here. It is a combination of arithmetic and geometric. So let's quickly see. It's a 3. It's a 3, it's a 9. Let's try to study and see the combination. Okay, let me use a circle. I have a 3. If I check 3, all right, look at this, 9. That's a difference of 6. Okay, I found my arithmetic. Do you see that? That's a 6, and that's a 6. That's my arithmetic. And the geometric is times 2 times 2 times 2. So D is 6 and R is 2. So it's not always straightforward. Sometimes you have to make sure you see what's going on. And that is what we have. Write down the next 2 terms. Okay, beautiful. So if you go on, you would notice that my next term, 4.1.1, is an arithmetic plus 6, 21. Then the next one is a geometric, 3 times 2, 6 times 2, 12 times 2 would give us 24. I hope we are good with that. I hope everybody's okay with that. Everybody good? Beautiful. Please let me know if there are questions. Prove without the use of a calculator, you see, that the sum of the series to infinity, when we say sum of the series to infinity, it only applies to a geometric. because the formula is A over 1 minus R. Now for the geometric, what do we have? 3. Oh, I think this, oh no, sorry, this question is a different question. It's a different one, it's not going to work. All right, this one is a different question because I see it's 4.2.1, so there was an error. However, let me create a question here because this one is, the question is for a different pattern. However, I want to create a question. Okay, so that's a question error there. But let me create a question. So please follow. Calculate, or what is the value of the sum of the first. All right, look at this. 13 terms. It's another principal question that you need to learn. Some of the first 13. We have a problem here. I cannot just use a formula. I have both an arithmetic and a geometric. So I have 3, I have 9, I have 15, I have 3, I have 6, I have 12. So you would notice that this is the geo and this is the arithmetic. Now, if I say 13, since there are, it's one arithmetic, one geometric, one arithmetic, one geometric. You would notice this is my arithmetic, geometric. Okay, so this is what we'll do. If we divide 13 by 2, what do you notice? It's 6,5. It means I have 6 arithmetic and 6 geometric. This is important, but this would only give me 12. The question is, which one is more? Is it arithmetic or is it geometric? I want to show you how to quickly look at it. Definitely I have 6 arithmetic, 6 geometric. Look at this number. This number is an odd number. So which one is your odd? Do you notice this is odd in terms of term number? This is even, that's number 2. Number 3 is odd. Number 4, term 4, even, odd, even. Do you see that? 1, this is 3, this is term 5, that's a T1, T2, T3, T4. And if I continue to T13, because it's odd, it has to be an arithmetic. It means that this therefore will have 13 terms, will be 7 arithmetic plus 6 geometric. I want to pause there. Do you understand what I did? There are 13 terms. If we pair them, arithmetic, geometric, arithmetic, geometric. When we get to pair number 6, we would have 12. The next one, because it's arithmetic that starts, it's going to be an arithmetic pattern. So I have 1 extra arithmetic. If it was 14, it would be 7, 7. I hope that makes sense. I hope that makes sense. Let me know. Because if you miss that part, you miss the question. So we have 7 arithmetic. So S13 would be S7 of the arithmetic plus S6 of the what? Geo. N over 2. Yes, talk to me there. Is that a question? Sir, you made a mistake. It's 3. 3 is an odd number, but you said it's... What do you mean? Can you talk to me? 3 is an odd, but you said it's odd. So I'm not really so sure. Oh, I think I get you. I'm looking, that's why I said term 1, odd. Term 2, 2. That's an even. All right? Even term. Odd term. Even. That's the even I'm talking about. 5. 6 is even. Is that okay? Don't look at these numbers. My odd term is arithmetic. My even term is geometric. My odd, arithmetic. My even, geo. My odd, arithmetic. That's what I'm referring to, not the values of the term. Ria, or is it Rio? Ria, do you understand what I just tried to explain that to you again? Ria, if you can unmute yourself, it's going to be quicker. So I will get you up to speed to what I'm talking about. There are 13 numbers. All right, she left. There are 13 numbers, guys. 13 of them. And we want to, so each pair, odd, even, odd, even, odd, even. It means the 13th one is an odd, right? Which is going to be an arithmetic. I hope it makes sense. Let me know if every other person is okay with that. Okay. So the arithmetic is going to be 7 over 2 plus 7 minus 1. And our arithmetic difference is 6. Plus, now the geometric, first time is also 3, 2, but there are 6 of them over 2 minus 1. You put that in a calculator and we are done. Let's see. Sir, what is the number below D? Equals to 6. Question 4.1.1, 21 and 24. Abongile, is that what you are asking? Question 4.1.1. All right, are you okay now? Just give me a thumbs up if you're okay now. Awesome. Can somebody please give me an answer? Put that in a calculator. Please, guys, don't let's waste time. Calculators quickly. The longer we wait, the less we do. 336 says confidence. Can somebody confirm for me? All right, thank you, Tata, Musadi, beautiful. 336. And I want us to try this. Let's see if we can prove this manually. Since it's not a big number, but please don't do manual stuff in the exam room. But just to show you that what we've done is perfectly okay. I want us to do it manually. So you said 336. Okay, so let's try to do it manually. I want you to see what's going on. All right. So, if I get my calculator, let's try manually. Let's start with the arithmetic. All right. So it's 3 plus 9 plus 15. We said it should be 7. Do you notice we're adding 6, right? 16 plus 15 plus 6 will be 21. That's number 4. Plus another 6 will be 27. Plus another 6 will be 33. 1, 2, 3, 4. This is 3. This is 6. We need one more. 39. Make sense? That's 7. Now let's go for the geometric. There are 6 of them. 3 times 2 is 6. Times 2 is 12. That's number 3. Times 2 is 24. That's number 4. Times 2 will be 48. Right? Times 2 will be 96. Check. 336. So that you trust the system of what we're doing. I hope it makes sense. So you're going to get this a lot. where you have two patterns. Two patterns. That's why I said we have 7 arithmetic and 6 geometric. So even if they give you first 50 terms, you don't have to do it manually. If it's 50, it's 12 arithmetic and 12 geometric. If it's 51, then you should know that, oh, in this case, the first one would be arithmetic. So I have 1 more arithmetic. I hope it makes sense. So if I had given you 51 terms, definitely it is 26 and 25. Or first, you start by saying it's 25 and 25, but that's 50. Which one is first? Arithmetic, geometric. The next one is an arithmetic, which makes it what? 26. All right, so that's the idea behind that. I'm moving on quickly. That other question, 4.2.1, is an error. Okay, so I'm moving on quickly. All right, let's look at this one. Consider the geometric. Does this series converge? First, look at it. They would not talk about convergence if it's not an infinity cell, infinity series. So this is infinity. That's why we bring in the rule of convergence. And what's the rule of convergence? I did say that S infinity will converge if R is between -1 and 1. So that's what you need to find. 6.1.1, what is R? 2 over 4, 1 over 2. Does this series converge? Yes. Why? Reason? R lies between -1 and 1. 6.1.2, S infinity, your formula, A over 1 minus R, 4 over 1 minus 2, no, 1 minus half. And that will give you 8. We're done with that question. Once we add up to 8, I explain what that means. Any other addition would not change the value. It's so small, it won't change the value. Are we okay here? Got to move? Okay. If you are kind enough and you want others to learn, I'll give you 5 seconds to take a picture. Otherwise, I'm moving on. I need to get to sigma as quickly as possible. There's a lot to do. Okay, next question. Consider the geometric progression. Now, determine the general. Now, look at this geometric progression. What do you notice? Do you notice that the denominator seems to be the same? It's repeated. That means that only the top is changing. So what do you think the general term would be? Only the top is changing. Sweet. So let's look at the numerator, the top. It's 1, 2, and 4. What is our R? 2. What is Tn? A, R to the power n minus 1. What is my A? My A is 1. My R is 2. Okay. So that is 2. So my general term for this particular question, I can simply write it as 2n over 3. Because I see that the 3 is constant. Let me see something. Yeah, my ratio is still 2. Okay. If you don't want to do it like that, look at what somebody else could have done. Let me try something else with you. All right. So my ratio would be 2 over 3 divided by what? 1 over 3, which will still give me 2, right? Now, Tn is A R to the power n minus 1. What's your A? 1 over 3, 2, n minus 1. Perfectly the same. Calculate the sum of the first 8 terms. We are using Sn. It's a geometric, so it's a r to the power n minus 1 over. This we have done. That's why I'm moving quickly. What's our a? 1 over 3. What's our r? Our r is 2. How many terms? Is S8. All right, somebody please, calculator. Somebody please, calculator. $85. Thank you very much. 85. All right. And we are done with that question. So the reason I'm doing so many questions is to make sure you see what's going on and you become comfortable with answering questions. That's why I love to do a lot of questions. By the time we repeat and repeat and repeat, don't get tired of repetition. Okay. Consider the sequence 3, 6, 9 to 60. Determine the number of terms. Let's see something here. Is this geometric or arithmetic? Let's look at it. What do you think this is? If I see the difference here is 3. Difference. So it's an arithmetic. Quickly. All right? It is an arithmetic. Determine the number of terms. I always first like to find what my Tn is. Okay. If you remember, this is going to be 3n. 3 minus 3 is 0. So 60 equals to 3n. N is 20. That's number 1. All right. Number 2. Determine the number of terms. All right. I know I'm looking for Sn. Since I know my first and my last, I did explain that I love to use this one. There are 20 terms, so it's 20 over 2. My first is 3, and that is 60. 63, 10, that will give us 630. Okay. And number 3, determine R. Remember, we did something like this when I created the question with 7. We created something like this. Determine the number of all natural numbers from 1 to 60, which are not multiples of 3. So S multiple plus S not multiple is equal to S total. Already we have this 630. What is S total? All right, we can use this one as well. From 1 to 60, so there are 60 numbers. 60 over 2, what is my first term? From 1 to 60. What will this give you? So that is 61 times 30, 1830. Somebody confirm? I have 61, yeah, that's correct. 183 and a 0. So S not multiples of 3, therefore, I'm glad we did this. 1830 minus 630. 30 would go, and 18 minus 6 would be what? 12. 1,200. If you are bored, you can start adding using a calculator when you are bored. Just say 1 plus 2, then you jump 3. 4, 5, you jump 6, 7, 8, you jump 9, plus 10, plus 11, up to 60 to confirm this answer. All right. We are done with this question. Let's move quickly again. Like I said, before we start something new, we just want to make sure everyone is on board, hence the pace. For those of you that have been in class, you would know that we're just solidifying what we have learned. Moving, if you are taking a picture, 5 seconds you have. Okay. Oh yeah, trigonometry. Given that cos theta, I told you what you should use sine theta as. We're going to do trigs. I think it's in term 2. All right, where theta is an acute angle. Prove that this is a geometric. Lovely. For me to prove, I need to find T2 over T1, which is sine 2 theta over, but what is sine 2 theta? 2 sine theta cos theta over cos theta. What do we have? 2 sine theta. Now let's confirm. T3 over T2. 4 sine squared theta cos theta over sine 2 theta, which is 4 sine squared theta cos theta over 2 sine theta cos theta. And then this would give us 2. All right, yes, we are done. It is because T2 over T1 is the same as T3 over T2. Therefore, it is a geometric series. Why series? Because there are additions there. Beautiful. Calculate the value of theta for which this will be converging. Okay, quickly. What is your rule for convergence? R would be, beautiful. So what is R? Negative 1 less than 2 sine theta. Okay, we are looking for theta. First, let's divide everything by 2. Negative half. Now, what do? We look for the arc sine of all of this. And what would that be? I think this should be 90. Negative 30. Negative 30, yep. Because sine negative 30. Oh, but they said, theta has to be acute. Ooh la 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 la. Theta has to be acute. But this is sine. If I press sine negative 30, you would see to give me negative half. Now I'm going to have a problem. Yes, talk to me here. Waruna?
Well, you said you forgot to divide the one on the right side
by 2. Thank you. Okay, so this should be 30. But now for theta to be acute, negative 30 is no longer acute. My answer, therefore, would be that. Negative 30 is no longer acute. You should know that from grade 11, trigonometry. So the real answer is negative 30 to 30 degrees, but there is a condition that it must be acute, which changes the entire system. Anything acute must be between 0 and 90. But I will do this. I have to put this there. Yeah, that's important. I have to put that. Why? Because the original answer, this is important. Yeah. Look at the original answer says numbers that are from negative 30 degrees to 30 degrees. But I cannot include the negatives. That's why I'm changing it to 0. But 0 is included in this range or in this domain. That's why I'm putting that there. I hope it makes sense for me to put that equal sign by the 0. 0 is part of the original answer. If I don't put an equal sign there, it means I'm excluding 0. But 0 is not excluded in our original answer. Okay, can we move? Let's see. How many questions did I give you? Oh, I'm sure this is the last one. I think I remember. Consider the geometric series for which values will this series converge. Again, for convergence, -1 less than r. I need to find r. What is r? T2 over T1. This examiner, I love this examiner. This examiner is playing with you. This can be written as 2x. So this is where algebra plays a big role. For those of you that missed my algebra, you were thinking, but it's grade 11. Now, flames. This is difference of two squares. So our r, now if you couldn't simplify that, then you are cooked. Very cooked. That's why you cannot play with algebra. All right, what do? Let's move the 4 over. It becomes negative, so -5. 1 minus 4, -3. Then we divide across by 2. All right, so our final answer would be what? -5 over 2 less than x less than -3 over 2. And that is that. If you want to take a picture quickly. Okay, I think we can now. There's one more. Let me see. Did I give you all of this? No. Guys, after this one, I'm going to jump to sigma notation. We will come back to all the rest because there's just too many questions. After this last one, we will jump to sigma notation so we can have something for the day, something new. Okay, let's walk through this together. Given a geometric sequence, determine the value of r. Okay, what is r? T2 over T1. They've already told us that it is a geometric, so you're not trying to prove. -12. Done. Number 2. Calculate n. But what is Tn? ar to the power n minus 1. 36. -1 over 2. Okay. Now we need to equate these to 9. So 36, this is my Tn. -1 over 2, n minus 1 should be equal to what? 9 over 4096. Let's divide both sides by 36. What would that be? Divide 9 over that by 36. It's going to be a very big number because we multiplied by 1 over the 6. Yeah, 16384. Okay. 16384. Do we want to use shift fact or we can use logs? My calculator doesn't have a shift fact, so I'm going to work offline first. Da-da-da-da-da-da. 16384, and what is the shift fact for that? That is 14. It's supposed to be 1 on the numerator. Are we talking about this question, Waruna?
Yes, when I say 9/4096 divided by 36, it gives me 1/16384.
Oh, is it 1 and I wrote 9?
Yes.
Okay, yeah, because it was beginning to not make sense to me. All right. Now, negative 1/2 n minus 1 is the same as 1/2 to the power 14. 2 to the power 14 would definitely give us that. Let's check on it. I'm sure you guys know how to use a shift fact. Like I told you, my calculator doesn't have that. All right, but I need us to look at something important. There's something I'm seeing here. Do you notice that this number here is a negative number? Okay. Please listen to me carefully here. There's a trick here. This number is a negative number, but this number is a positive number. Right. It means my exponent has to be what? Positive. Okay, it will still work. So, n minus 1 equals to 14, n equals to 15. It will still work. It will still work. Let's test it. Open bracket, negative 1/2, and then we say 15 minus 1. Perfect. N equals to 14. N equals to 15 rather. Okay. Are we good there? Let me squeeze number 3 here. S infinity. We just use the formula quickly. 36 over 1 minus negative half. And what will this be? 36. Somebody give me an answer. That is 36, 3/2. 36 divided by 3 would be what? 12, 24. Answer should be about 24. Confirm. 24. Beautiful. Now look at the next one. The next one is a very interesting piece. Very, very interesting piece. We did something similar to this, but this one might take up a different approach. So guys, I am quickly giving you exposure. You see this question in a test, you just ace it while every other person will be struggling. Now, for this particular one, look at what we would do. It's a geometric, right? Remember? So, what is T1? Don't work with T's all the time. Please work with A's. A, let's see first. AR squared, AR to the power 4, AR to the power 6, AR to the power 498. We'll see what's going to happen. So always break it down. What is T2? It is AR, AR to the power 3, that's T4, AR to the power 5, AR to the power 7, and AR to the power 499. Interesting. You're going to love this. You would love this. How do I simplify this? Do you notice? Let's look at the pattern. Top and bottom. There's no R here, but there's an R here. There are two of them there. There are three there. There are four there. Like that. So, look at this game. I'd lift the top. I'd lift the top. We're going to use laws of exponents and be smart about that. Now, check this. Let's factor out R. Let's remove one R. What are we going to have left here? AR squared, because we've removed one R. AR to the power 4, AR to the power 6. I hope you see the laws of exponent there. Do you notice that whole thing would cancel and we are left with 1 over R, which is 1 over negative half. And that would be 2. Exposure. Exposure is too important in maths. If you are the type that you just do what you do in class, you're going to suffer in maths. If you don't want to suffer in maths, wherever you stop in class, you push forward. You look for questions. Get exposed. I promise you the next time you see something like this, this is your first thought that let's change it. Let's see if we can cancel some stuff. So you will be quicker in getting work done than any other person who hasn't seen such questions before. All right, please let's send a picture if you can. We now need to quickly run to the matter for the day for about 30 minutes or so. Anybody sending a picture? Okay, now let's go for sigma notation. Whichever questions that we have, guys, we'll have one session where it's just all of these questions. We're going to have a session where we just work with questions. So I'm going to push them down. But for now, so we get into something new today, sigma notation. We use this in physics, sigma notation. So that symbol E there is called a sigma. So let's get on with today's work, sigma notation. Now, what does sigma mean? The symbol sigma is a symbol for sum. That's all. Simply means Sn. And then that's it. It simply means Sn. But the expression is fully written as sigma. Then you put the Tn. You look for Tn. N, I'll say A over B here, A and B, where A is the first position NB is, or let me say position of the first term is the position of the first term. All right. And B is the position of the last. All right. I'm going to slow down now since we're learning something new. Position of the first and position of the last. Position of the first and position of the last. Now, let's go into real work. Example. Consider 2 plus 5 plus 8 plus 11 plus 15 plus 18 represent the above in a sigma. Oh, wait, there's something I need to quickly write there. Just one space there, quickly. The number of terms is always top minus bottom plus 1. That is B minus A plus 1. Number of terms is top minus bottom plus 1. I'll show you what I mean. Top minus bottom plus 1. Okay, so we have this example that I want us to look at, and I want us to represent this in a sigma notation. So the first thing is to look for Tn. Step 1. Find Tn. We all know how to find Tn. I'm sure you still remember what I taught you. It's 2, 5, 8, that's 3, that's 3. 2 minus 3 is -1, and I have 3n. And then I'll come here and say that 3n minus 1. Now, how many terms are here? 1, 2, 3, 4, 5, 6. First position and the sixth position. Please take note. Those top and bottoms are position. Top and bottom position. I can omit this bracket. It will still be the same. This is position 1, which is my T1. And this is position 6, which is my T6. Did that make sense? Did you get it? So that, guys, if I throw in a 1 here, 3 times 1, 3 minus 1, 2. Check that. And 6, 3 times 6. Did I make a mistake here? 11, oh yeah, sorry. It's 14 and 17. Please change this. I was adding 3. 14 and 17. 18. Yep. So that if I throw in my 6, 3 times 6 is 18, minus 1, 17. So this is this. Are we good, everybody? Did that make sense? So we are going to be able to move from the top to the bottom and top back to the bottom. Let me give you one to do for me. Let me give you one to do. Represent this. Represent these two. Represent the following. I'll just give you 2 questions in sigma notation. Number 1. I'd actually give you 3. Number 1. It has to be plus. You can start with the first one already. Yeah. I want you to try. I'm going to give you 10 minutes. Try. Remember the steps. Get Tn. Make it 12. Try for me. Okay. So what's the timer for? Abongile, the timer is for the work to be done. All right, the first one. All of these are actually additions. It's -2 plus -6 plus. All right. So there's a plus in between that we have hidden. Okay, so there's a plus there. There's a plus there. So you would find, what's our Tn? Our Tn for the first one, number 1. So what's the difference? What's the common difference? -2. So it's going to be, you're saying -6 minus -2, which is going to be what? -4. And then we put that there. That gives me my Tn to be what? -4n. And 4 minus 2 is that. So my number 1 would be sigma of -4n plus 2. How many terms are here? 1, 2, 3, 4, 5. Where n is 1 up to 5. Let me know if your number 1 is okay, if you agree with me. It's that simple, that's straightforward. Number 2. Now, instantly you should see number 2. Number 2 is geometric already, So you must identify the type of pattern. And R is what? 1/2. So you must learn to quickly see that it's geometric. A into R n minus 1. So number 2 would give me 3 multiplied by 1/2 n minus 1. 1, 2, 3, 4, 5, 6. N equals to 1 to 6. Number 3. You would quickly see number 3 as also there's a difference of 3. Difference. So it gives me a geometric where my Tn therefore is 3n plus 1. The question is, so we're starting from position number 1. To what position? We need to go find that out. So 64, all of this is part of your work. That would be 63 and n would be 20. Is that correct? 21. 21. So from position 1 to position 21. And number 4, again, number 4, automatically I see that it is a geometric, but it is to infinity. So from position 1 to infinity, what is my Tn? It is A, R. So I have 2. Please, are we okay with that? Is there any question, please? Are we okay with this? Okay, so that's the first part of sigma. That is the first part of sigma. The second part of sigma will be the examiner would give you the sigma itself and they tell you to evaluate. They'll give you sigma and they tell you to evaluate. Can I move to the next? Can I move my slide? We have 15 minutes or 12 here. Okay, so you would see questions like this now. Evaluate. I'll do about 3 of them. Evaluate that. Evaluate simply means give the value of that. Give the value of that. Never forget. So steps. Number 1, identify the type of pattern. Usually, if it's linear like this, it will be arithmetic, but I prefer that learners identify find T1, find T2, find the first three, T1, T2. For T1, you would substitute n as 1. For T2, you will substitute n as 2. Use this to check for D or R. And this is helping you to identify the type of pattern. Step 2. Calculate n. Ooh, my spelling. Calculate n by saying n equals to top minus bottom plus 1. 3. Use the appropriate SN formula. Use the appropriate SN formula. That is how that's going to work. So write that. We look at 4 examples as time may allow us. No, we have 10 minutes. But I want to try to look at, then give you some questions to do. Abongiles Wide, looks like this is my first time of having you in class. Is this your first time, Bongi? Welcome, Nana. You've missed a lot. This is lesson 4. So you need to go to the YouTube channel and watch lesson 1, 2, 3. It will really assist you. Okay. All right, 30 more seconds. 30 more seconds so we can look at how to evaluate that. Once we understand the simple basic ones, we can now use that knowledge to deal with difficult questions. Okay, so what will I do? I have to find T1 first. What is T1? I'll just come and substitute n as 1. And that will give me 5. What is T2? And that will give me 8. What is T3? Until we become until we become masters of this, and then we can identify just by looking at the part, the Tn. Once we know how to identify by looking at Tn, this first part really, we can overlook it. And you would see here, it's 3, 3. It's a difference. This tells me it's arithmetic. And you will already see because it's a linear pattern. Okay, it's linear. The difference is 3. Beautiful. How many terms are here? Top minus bottom plus 1. There are 8 of them. I can now bring in my SN formula. If I like, I can use this one because it looks like I have everything I need. S8, 8 over 2. What is my first term? I'm going to always need that. 5 plus. There are 8 of them, so 8 minus 1, and the difference is 3. Somebody kind enough, put that in a calculator and get me an answer. Can we confirm? Confidence says 124. All right. Waruda confirms 124. I want to show you the second option. Since I know it's arithmetic, I could find the last term by saying 3. My last position is position 8 plus 2. And that will give me 26. Then I can use this formula. A plus L. S8. 8 over 2. My first one is 5. And the last one is 26. Can we confirm if it will give us the same answer? That is 31. 31 times 4 will be what? 124. Yes, perfect. So once I identify that, I can always work. Did that make sense to us? You first identify the type of pattern, then you calculate n, top minus bottom, and use the appropriate SN formula. Can we try another one? If you're ready. If you are ready. Okay. Let's try another one. Do you want to try this for me? Follow the same steps. Let me give you 5 minutes. Quickly, 5 minutes. All right, I'm sure you are done. First, what is your T1? Look at this one. Very interesting. What is your T1? That is my T1. I'm starting from position number 3. So minus 6, 1 minus 6. If you got that wrong, then your whole answer is wrong. Did that make sense to you? That's your first position. N is 3. Okay, so we can switch things around. I know it's going to be an arithmetic, but if just for the next one will be 4. 1 minus 8 would be what? Negative 7. T3. So we do this until we perfect it, right? 1 minus 10, negative 11. And the difference, you can already see the difference. The difference is negative 2. How many terms are here? Top minus bottom plus 1. So 13 minus 3. There are 10 terms there. Let's prove that. Look at this. If I start from that, I want to really prove that. So basically, this is what I'm saying. T10, T11. That's what we are really saying. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do you see that? That is everything that we are really doing. We are adding from T3 to T12, and there are 10 terms. How do I get the 10? Top minus bottom plus 1. But I don't need all of that anymore. I can just say Sn is n over 2 2a plus n minus 1 d. What is n? There are 10 terms over 2. What's our first term? That one you have to calculate. And 10 minus 1 is 9. All right, what is your answer here? Is there anybody who did exactly this? Yes, I need an answer quickly. We've run out of time. Okay, what's wrong? Somebody's giving me a thumbs down there. What are you trying to say? Did I lose you? Let me know if I lost you there. I saw a thumbs, I saw one finger pointing to the earth. Negative 140. All right. Guys, did it make sense? Are you okay with it? Are you okay with what I did? Every step. Thank you. Negative 140 as well. I've got Tiseto there, Oluetu. Confidence. Okay. So that is how we deal with sigma notation. Let's do 2 more. If you are lost, please do ask. Let's take some 10 minutes to, just to conclude today. But I want you to try this for me. Use your knowledge of what we've just done. Use your notes. Step 1, step 2, step 3. You will be fine. Got an answer for me? Sorry, Tata, I'm just looking at your message. Mike, it's 1 minus n, not n minus 1. So these are the things you would see. But if you follow what I ask you to do, you will be fine. What is your first term? 2 into 2, 1 minus 4. And what would that be? Now, this is where they really want to catch you, all right? That's why I always like you to write your T1, T2, and T3 out. Do it out. Okay, what would this be? That is 2 over 8. That should give you 1 over 4. Please confirm that for me. One over 4. Thank you, confidence. Then we have the next one. 1 minus 5. And that should be 1 over 8. Because that's 1 over 16. And then T3. 1 minus 6. And that should be 1 over 16. Instantly, I am going to quickly identify this. Look, the fact that I am seeing something exponential already tells me it's geometric. But listen, find out what is R. T2. I said we will do this until you become perfect. And this will be 1 over 2. What about T3 over T2? 1 over 16 divided by 1 over 8. So it's a geometric identify. And the reason I gave you something like this is to let you see that your R is not 2 because of this. You see, if I wrote it as n minus 1, then my R would have been 2. But I don't want you to pick it from there. That's where our errors start from. How many numbers are here? 15 minus 4 plus 1. What would that give us? That would give us 12, I think. So Sn equals to what? It's a geometric. A r to the power n minus 1 over r minus 1. What is our first term? 1 over 4. What is our r? It's a fraction. 1 over 2. So this is S12 over, and what's our answer? We're done for today once we get this done. Then we'll start seeing some complex questions along the way, but this is the basic part of the work. Let me see your answer quickly. Okay, guys, we can't be typing on the calculator for so long. Oluwetu, yes?
Yeah, I have a question. Is it possible if we're dealing with the geometric sequence, can we use, when we're calculating the sum, can we use the last term formula?
Which one?
The one for the linear sequence.
You can use linear for geometric.
Oh, okay. Okay.
Make sense?
Okay.
Good. That's why we first need to identify. And if you check my note, number 3 says use the appropriate one. Okay. Are you giving me 0.5 here?
Okay.
Okay. Thank you, Oluwetu. You good? Confidence. Is the answer 0.5? You sure? Why don't I trust this answer? Can I just check quickly? I'm having a bit of a doubt there. I'm just having a bit of... It's possible though, because I see it's going to be quite a small, yeah, it's possible. Okay, you're running off. 1495 8192, 1495 over 8192, which is approximately 0,499, which is 0,5. Okay, I hope it makes sense, everybody. Makes sense? Yeah, you find confidence. Makes sense. So if I give you this, let's have one more slide. If I give you this, what will it be here? Look, because I am already seeing I'm already seeing infinity. I already know that it is this formula. This is the only formula we have to infinity. That is telling me I have to get to infinity. So all I need to do is to find my A, which is the first term. I need to find my R. And in this case, my R would be 1 over 3. I want you to notice what I did here now. This is no longer 1 minus n. This is n minus 1. It looks like the original stuff. So what is my A, which is my T1? 3. 1 minus 1. And your answer there would be 3. That's my A. So if you see this, look, I just didn't want to go this way. I want us to... Now, if you look at that, you can see already A, R. Please look at this, n minus 1, n minus 1. That's why my R, it's different from this one. Is that okay? Let me show you something quickly on this one, everybody. If you want to do this, look at this, 2, 2, 1 minus n. If I want to rewrite this, check. This can be written as negative 1 into n minus 1. Now, what is 2 to the power negative 1? It is half. Then I have my n minus 1. Check. A, R to the power n. Now I have written them. Okay, no. What did I do here? I wrote that. What did I do wrong? Half. Because my A there is 4. 1 over 4. But it's always nicer. Please just do this N1, T1, T2, and T3. All right. So my A here, my first term. Okay, the problem, all right, I see. You see, this one is starting from T4. N is 4. That's why my A is different. Do you see that? I am starting from position number 4. So it's always good to just walk this way. It makes it very, very easy for you. Okay. Are we good, everybody? So with this one, you can, just for safety, it won't take you time. You'd rather be sure than make assumptions. What is T2? 3, 1 over 3, 2 minus 1. What would that be? That would be 1. Then what is T3? 3. You know, there's nothing wrong with being sure. 1 over 3. Because that's 1 over 9. Yeah. So my R will be what? T2 over T1, which is 1 over 3. And that is the same as T3 over T2. 1 over 3 divided by 1. So we're good. And it's summed to infinity. What is my A? 3 over 1 minus, what is my R? 1 over 3. And what would your answer be? 9 over 2, I think. confirm for me? Yeah, 4,5, 9 over 2. And that's it. Guys, I hope sigma notation makes sense to you now. It gets tricky. It really gets very, very tricky. You know, for the homework, let me do this. I am going to send the homework on the group. I do have them, but I'll do the screenshot for you. Ooh, beautiful. You see, everything is sigma. Sigma. Yeah, everything is sigma. Beautiful. Sigma. So let me send this to the group. I think I'll have about 10 or so. Oh, can you see? It's quite a lot. Yeah, I'm going to send this to the group and we will take it from there. Are we okay with our lesson on sigma notation? You'd find the homework on the group for you to do. I think I wanted one more class, but not tomorrow because you need time to do this. I think, guys, our final class for this whole session will be done on Monday. Final, then you guys can take your break. Final session will be done on Monday, and then you guys can take your break. I think that should be fair enough, right? Fair enough. Okay. So that over the weekend, you can try to look at the questions that I'm going to send you. Practice. We sort everything out on Monday. Then I'll leave you to take a break. January, you work on your own. Look for questions. By the time you get to school, you are extra solid. And we here will be starting topic number 2. We always want to be ahead of your school so that it gives you time to revise. So when you're doing this at school, what are you doing? You're revising. Makes sense. Have a lovely evening, everybody.